Hi there. I wanted to follow up on the video that I had published on how to create the views, the multi-view setup for X-Plane 11, and just a little general about multiple monitors for use in flight simming. I had a long career as an airline pilot. I was a military pilot before that and flew general aviation also. And when I first got to simulators, I really wanted to make the experience as realistic as possible. And I found that I tried Track IR, and I found Track IR to be a bit difficult for me. For example, using Track IR, and I'm using a camera now to simulate that, but as you turn your head, you turn proportionally and you get a view that's decent. It's a geometrically correct view, but you have to turn your head to see that view. The reason that's not completely realistic, at least it wasn't for me, is that when I want to look at the instrument panel, now I use Air Manager for the flight instrument panel on a separate monitor, actually run by a separate computer. That allows me to use all the assets that my graphics card and CPU have on my most powerful computer to run the outside visual. But as I'm am using this monitor, I have it mounted in front of, as you can see, and higher than the actual outside view, because I have it set with maybe I can show you, it's a pole mount so that I can raise that up and down depending on the aircraft to match the cutoff angle of the view so that it matches what I would see actually in the aircraft. You know, the dash of an airplane, especially like a Cessna, it covers a great deal of the forward view. And to use that, I have to run this monitor quite high to give me a realistic view out the front. Now, of course, you could use a virtual cockpit, but I like running without the overhead of trying to draw the cockpit. Drawing all those cockpit items, all those polygons, all those the rendering of all those items in the cockpit can slow things down a bit. So I decided to go with a multiple monitor because, as I said, when you want to look at the instruments in the airplane with Track IR, you have to tilt your head down to see the instruments, then you have to tilt your head back up. In reality, I'll back off here a bit. In reality, when you're flying a real airplane, you just glance your eyes down and glance your eyes right back up. There's no head movement required. Also, I just found it hard to get used to. So I decided to go with a multiple monitor setup. I started out with three 23-inch monitors. And as you'll see later in this presentation, the problem you have is those monitors have to be pretty close to you to get a realistic view. I'll show you the geometry of that later. But because of that, it allows very little room to get your yoke in this second monitor in front of it. In fact, in my 23-inch setup, I actually had it packed, one monitor, this lower monitor with my instrument panel, all the way up against, just almost completely against the monitor that was higher, that was creating the external view. So I find it works, we'll see that there's limitations in that by having larger monitors, the geometry works out better for allowing much more room for a cockpit structure or a panel or even a virtual panel on instrumentation that's on a monitor, LCD monitor, and to have room for your yoke in front of that. So as we go on here, I want to just talk about I started off with a stretched view because, of course, X-Plane only supported multiple views by having really multiple computers, or some tricks where you could run multiple instances, just multiple copies of X-Plane, but the processing requirements were quite high. So I just used this stretch with the surround system. And as you saw in my previous video, it's just not realistic. Things out in front look further away than they should in real life, and things on the edge of the screen look closer. Now this is a multi-view setup that we talked about in the other video, and you can see that right to the edge of the video it's very accurate. So It's just like I have a single camera with the 45-degree field of view, which is what I have here, and then another camera with another 45-degree field of view, and another camera with another 45 field of view. Now, this was available, I think, in prepared for a while, but this is new to X-Plane, and it really adds a lot to the realism. You know, another thing that you lose when you use a track IR is that peripheral vision. You know, my field of view is much wider than the camera can see now. In fact, I can see, I'll just show you with my own eyes, I can see out to about right there in my peripheral vision on that side, and the peripheral vision about there on the other side. And that is a cue that gives you a sense of speed. It gives you a sense of, sometimes you can sense bank angle and other things in your peripheral vision that's just not available with track IR. So nothing against track IR, I think it's a great solution, but I think now that computers are faster, that like a 1070 graphic card for under $400 is what I'm using, and it's able to run these 3 monitors. Now, obviously with X-Plane 11, I've seen a little reduction in the speed with moderately high settings of objects, and you can see I have pretty good a number of objects out there. I think this is like one step down from the highest. I'm only getting about 26 or 28 frames per second. I'd like to see that upper in the 45 to 60 range, ideally for flight training. And I think I would have to turn this down a little if I wanted to get optimal flight training, because the motion is where you really get the sense of realism, the reaction, the presence that you feel when you're in a simulator that's very accurate. So let's go take a look at the layout of how the geometry works, how to find the perfect eye position, and how to lay the monitors out to optimize your view.
Now the first concept is field of view. The field of view is the lateral angle between the left and the right limits of the view that's displayed on the monitor. That's the value that you select in X-Plane. Now the geometry is that we want our eye in a position so that the angle between the left and the right sides of the screen equal that value. Now there's only one correct distance from the screen that will give you that perfect angle. Now in this view you can see that the distance in a 90-degree field of view, the example here, is 0.5 times the width of the monitor. The eye needs to be that distance from the monitor, and it needs to be centered on the monitor, and it needs to be looking perpendicular to the monitor. That's the perfect eye position where what you see will match what you should see if you were looking with the naked eye at that scene. Now, to get an idea of what we're talking about, let's take a look at the field of view of 90 degrees using X-Plane. You can see this is a pretty wide field of view, and the end of the runway looks like it's a long way down there. The mountains are small, and there's quite a lot of stuff visible along the sides of the runway. Also note that it's slightly distorted as we get closer to the left and right edges of the screen. Now here's an image similar to the diagram before, but with a 60-degree field of view. You can see that the distance for the perfect viewing angle is back slightly further at 0.866 times the width of the monitor. Putting that in terms of actual numbers, for a 23-inch monitor, that would give us about 17.5 inches for the perfect viewing angle. That's pretty close to the monitor, and sometimes can create difficulties where you can see the pixels. And this is what the 60-degree field of view looks like. Notice that there's less visible on the sides due to the narrower field, but the end of the runway doesn't look quite so far, and the mountains are slightly bigger. Also note that the view is slightly less distorted due to the narrower viewing angle. Now let's look at a 45-degree field of view. You see that the ideal viewing distance is even further back now at 1.21 times the width of the monitor. This is about the default field of view for X-plane. Now let's look at 45 degrees field of view. Note the mountains are bigger, the end of the runway seems clearer and closer, and the side view offers less distortion. Also note that due to the 16:9 aspect ratio, a reduced horizontal field of view also results in a reduced vertical field of view, and you can see less sky. A 30-degree field of view moves us back even further, the 1.866 times the width of the monitor. This makes it difficult for us to see the pixels, which is a good thing, but it also requires a large number of monitors to create any considerable total field of view in a multi-monitor setup. 30 degrees field of view offers a very low distortion image, but notice there's not much sky left due to the narrowing vertical field of view also. So let's take a look at each of those field of views one more time to compare them against each other as a comparison. And remember that we're starting now with the narrowest 30-degree field of view. And here's 45 degrees field of view once again. And here's 60 degrees field of view. And here's the widest field of view, 90 degrees. And let's zoom back in through each of those views one more time. 90, 60, 45, 30. Now that we have a basic understanding of field of view, let's use that to consider how we will put that into a layout of multiple monitors using X-Plane's great new multi-view possibilities. Let's start with 3 monitors edge to edge on a single plane, creating a widescreen monitor, much like some of the wider monitors that can be purchased today. We can think of these as one big monitor with the width equal to the sum of the 3 monitors. Then we can do our field of view calculations just as though it was a single monitor, albeit very wide and not very high. Not very practical for a sim setup. Now let's create a multi-monitor setup where we rotate the left and right, or the outer monitors, inward at an angle equal to the field of view. Note that the perpendicular lines all intersect at a single point, which coincidentally is equal to the distance to the ideal field of view eye point. Since each monitor has a 30-degree field of view, rotated left, right, and center, it gives us a total field of view of 90 degrees, but without the distortion associated with a surround system, where the image is just stretched. So here's a setup where we've rotated the monitors to 45 degrees in on each side. This is a setup like the one I currently have, and you saw in the opening videos. As a reminder from earlier, the 45-degree field of view yields a distance for ideal viewing at 1.21 times the width of the monitor. And 45 degrees field of view looks like this. A good trade-off between lateral field of view and vertical field of view. So we now have 3 monitors, each with a 45-degree field of view that add to a total of 135 degrees field of view. So at next plane, our monitors would be set up with the left monitor with a minus 45 lateral offset, 45-degree field of view. Center monitor, 0 offset with a 45-degree field of view. And the right monitor with a plus 45-degree offset and a 45-degree field of view. But given enough CPU and GPU power, we're not limited to only 3 monitors. X-Plane will support a large number of monitors. A good possibility, if you wanted more visual field of view, is to use an additional 2 monitors to create a 5-monitor set, as shown here. With 5 monitors, each with a 45-degree field of view, it gives us a total field of view of 225 degrees, which means that you can look out the wing and actually look about 22.5 degrees behind the wing line or the lateral axis of the aircraft. The geometry of this layout gives us a total width of the layout, which would be the same for 3 monitors, as you can see, of 2.42 times the width of the monitor. And what does that mean? Well, it means you have to be able to fit your complete simulator structure or whatever you're using for controls or cockpit or even a complete aircraft structure inside that area. For my layout with 49-inch monitors that are 43 inches wide, that means the total width would be 104 inches or 8 foot 8 inches. With the monitors as big as they're becoming, 60 and even 80 inches, you can imagine it takes a pretty good size room to hold your simulator. We're not limited to the 45 degrees, of course. One novel approach I saw by Michael Brown, he's at X-Force PC, involved a 70-degree field of view for each monitor. This allows a behind-the-wing field of view, looking 15 degrees behind the wing, of course. However, it does have some disadvantages. For one, the viewing distance that's ideal is only 0.71 times the width of the monitor, which means you're sitting pretty close and you're probably going to see some pixelation on the screen. The second disadvantage is with that 70-degree field of view, you're going to have more distortion towards the edge of the images, just like we talked about before. Still, this is a pretty effective way of allowing you to have a true wraparound visual. Of course, there's no reason you couldn't use a 60-degree field of view as shown here, and with 3 monitors you could get 180 degrees field of view. It would also move you a bit further back from the screen, which might help. I haven't tried this one though. Although there's many ways to set up your multiple monitor setup, the basic principles remain the same. And a multi-monitor setup can greatly increase the realism of your flight simming experience. Now let's consider how we're going to set up the correct eye viewing position in the vertical. Generally speaking, we want the eye to be level with the horizon on the screens, which for X-Plane is generally the center of the screen. If the eye point is above the center line, it will look something like this. You can see how the runway edge outlined in red and the horizon are bent downward on the outward monitors. Similarly, if the eye position is below the level line, the runway edges are bent upward. Finally, if the eye is in the proper position, centered on the monitors, the lines are straight and look true to life. So let's now consider the placement of the flight controls and any additional monitors with respect to the visuals that we've talked about laying out in various configurations before. In the case where the monitor is not so large, like you see here, and the viewing distance is short, as long as the flight controls can fit beneath the monitor, as you see here, there's no problem. But if the monitor extends below the flight controls or whatever panel we may use, we have a problem. That requires the use of a bigger monitor. Let me show you an example. My first attempt at multi-monitor setups for X-Plane, I used a 3-monitor setup with a 45-degree angle field of view for the 3 monitors that I used. As you can see above, I wanted to use a 4th monitor driven by another computer using Air Manager to provide instrumentation. I wanted to set the top of the monitor approximately where the cutoff angle or the top of the instrument panel was on the actual simulator. In order to be able to get the yoke and my arm between that and in front of the instrument monitor, I needed to sit back a considerable distance. With a 23-inch monitor, I just frankly had to lean forward to get to the proper eye position. Let's look at a photo of that initial setup. I mounted the instrument panel monitor so that it could be moved up and down to match the top of the instrument panel. This is another view of that setup from the top, and you can see how there's a certain distance that's going to be required, and the location of the controls in the pilot's seat need to be adjusted so that the eye is in the proper position for the perfect viewing angle, based on the formulas we looked at earlier. But even without formulas, the goal is to place the eye centered on and perpendicular to each of the visual monitors. With a small setup like my original simulator, there really isn't a lot of room to spare. Adding a larger visual monitors and the accompanying longer ideal viewing distance allows quite a bit of room to include monitors, flight controls, and instrumentation that you might want to include. And the instrumentation and flight controls also need to be able to fit in the lateral layout of the monitors and allow proper eye position. For multiple pilot cockpits, this can require a pretty good size layout of very large monitors, and also will not allow both pilots to have good eye position, since there is only one accurate position in the entire cockpit. While both pilots will see the same images on each monitor, the pilot in the improper position will not see the correct field of view to match that which is displayed. The final topic I'd like to address in this video is bezel correction. Bezel correction can add a great amount of realism to your visual layout. Now imagine the image above was a single image that had been cut right between the monitors, and then the two halves pulled outward until they aligned with the edges of the bezel on both sides. You can see how the line markings on the runway in the foreground kind of jump across that area. It's as though there's nothing in that area except a space between the images. Note the runway light that's almost centered in the image to the right of the bezel. And I'll show you what happens when we add bezel correction. Now with bezel correction added, it's as though those two halves were pulled back together to the center of the bezel and are being obscured by the bezel itself. The taxiway light that was visible before is now behind the bezel, and the runway markings in the foreground appear to be lined up correctly across the bezel area. Let's look at uncorrected again. Notice the jog as the runway markings pass across the bezel. And here we are again with the corrected view. It looks like the image is continuous behind the bezel, like a post or something blocking the view. So bezel correction is obviously better, but how do we set things up in X-plane 11 to get the correct bezel correction amount? Hopefully this diagram helps explain it a bit. Since the bezels are visible, we include them in the width of the monitor when calculating the field of view uncorrected. This field of view is equal to the amount of offset applied to each monitor around the layout. The bright green arc is the bezel corrected field of view. It is from the inner edge of both of the bezel edges and it represents the amount that can be shown on the actual LCD screen. There are also formulas here to calculate the optimum viewing distance from the screen to the eye and the radius of the circle that represents the arc through each of the edges of the viewing screen. Let's try looking at a close-up of the red circled area to better understand the geometry involved. I'm not going to belabor the math, but you can see here that there are formulas that you can calculate the small angle, which I call here theta, which is the width, an angular width of one bezel, and doubling that, as you see in the bottom formula, doubles that for the total bezel width to subtract from the uncorrected field of view to determine the field of view that we need to display in X-plane so that the monitor displays an amount equal to what we would see visually in the area between the two bezels. One caveat, if you're going to do the calculations, be sure to use your calculator set to degrees instead of radians. An alternate way to calculate the corrected field of view is to take the undercorrected and multiply it times the ratio of the screen width to the monitor width. And this seems to work pretty well when the field of view is not too large and the bezels are not very wide. I'll show you some numbers to see how that works. Now this chart shows for my monitor width of 43 degrees and a bezel width of 0.25 on each side of the monitor that if you come down to the 45 degree field of view line, the second from the bottom, you can see that the distance that I need to be is 51.9 inches. You can see the radius there, 56 to the corners, and if you look carefully you can see that the bezel corrected is 44.45. But if I use the alternate method I get 44.48. So it's only a 0.06% difference, so the error is not bad. If you look at even 60 degrees, with that narrow bezel, it's only 0.12%. And even up at 90 degrees field of view, with that small bezel, it is only 0.32%, or the difference between 88.67 and 88.95. Certainly plenty good for the settings on X-plane. Now let's look what happens if we use a 1-inch bezel. So you can see here, again, looking down at the 45 degree field of view line, second from the bottom, that the difference is only 0.27%, or the difference between 42.79 and 42.91. And even if you go to 90 degrees, it's only 84.6 and 85.81. So what's the bottom line? I'm not sure it's really worth all the math to go through the process of calculating the exact field of view correction if you can use this alternate method and you get very close numbers. If you saw my previous video about how to set up the multi-view on X-plane, you know that I was just guessing initially. I didn't have any idea how to calculate it, and I was just trying values and slowly narrowed in on the right setting. It is interesting that I came up with 44.5, which is almost exactly equal to what the calculations show with either method. Well, in summary, I think we've looked at multi-monitor setups using multi-view capabilities of X-Plane 11 and decided that it really is an awesome way to go if you want an immersive view. We looked at the fact that big screen TVs are getting cheaper, and even with a GTX 1070, which is an under $400 video card, and a 3.5 gigahertz i7 CPU, you can get reasonable frame rates to add for a very realistic view. We looked at field of view and talked about there's only really one distance that's perfect for a specific field of view based on the width of a monitor. And we also looked at various possible layouts for multi-monitor systems, but they all have one thing in common. The perfect eye position is centered on the monitor and looking perpendicular to the monitor, and when we lay them out correctly, that point will be the same for all the monitors. And of course you can look at that math again and freeze frame on some of those diagrams if you want to do that. Finally, we looked at the mathematics of the bezel correction, and I guess the conclusion was that all the trigonometry really isn't worth it. Generally speaking, the estimated method will give you a result that is just about as accurate and suitable for most users. So as a pilot of over 40 years flying civilian light airplanes, military fighters, and also for the airlines, I can tell you that this is a very good setup that we get with X-Plane, and X-Plane is really an awesome simulator. The latest changes are making it awesome. I think it's going to only get better, and as the computer technology catches up with Austin Meyer, I think we're going to find unbelievable possibilities in the future, including VR. I'm sure that's going to be awesome too. So I hope you enjoyed this, and I wish you would subscribe if you think it's worthwhile. I'm going to try to do some more stuff in the future. Thank you.